My name is Elliot Menashe. I'm going to talk about plant stormwater erosion control and how it is affected and affects slope stability. I'll be talking a bit about the role in vegetation and benefits of native vegetation, and a few more management tips for how to live on the edge. As John has made very clear, erosion and landslides are a fact of life throughout the Puget Sound region. It's a very young landscape. It's kind of rambunctious, and it's been eroding since the last glacier receded. Shorelines are very temporary places. They can be risky places to live, as you've seen. Regardless of the risks, people want to live on the edge. So we build permanent structures in temporary locations. Poor development management practices can make shorelines even more temporary. Or you can make your property less temporary by improving your management. Vegetation management is a key aspect of good shoreline management. You're probably asking, why is vegetation so important? Well, I'll tell you. Forests protect land in two basic ways. Trees, shrubs, and ground covers provide hydrological benefits and structural soil reinforcement. The hydrologic benefits include metering rainfall. John talked about the effects of rainfall. Rain falls on the land. It's intercepted by the tree canopy. Water adheres to the leaves and to the stems and is interrupted and then falls slowly through or flows down the stems, hits the shrub layer, and the process continues. And then it hits the ground covers, process continues, and finally it hits the soil, and very little rainfall enters the soil. And what does, recharges the aquifers. I don't know how many of you are on wells. I am, and recharging aquifers is very important. Trees and other vegetation also take up water through evaporation on the leaves and transpiration of the vegetation, which helps to maintain its biologic structures. So all of this reduces the process of soil saturation, which reduces stormwater, which reduces runoff and minimizes erosion and reduces landslide. Conifers evapotranspire and keep their needles all year rather than hardwoods, which are deciduous and lose their leaves in the fall, right about the time the rains are increasing. So just an aside, the original composition of forests in the Northwest were about 80% conifers and 20% hardwood. Through logging and other human impacts, that ratio has changed quite a bit, so that now the ratio of hardwood to conifer is about probably 60 to 70% hardwoods and only a very reduced conifer component. The other way that vegetation helps to maintain slopes is through structural soil reinforcement. We're going to talk a little bit about that. Ground covers and shrub roots hold the soil particles. Shrub and tree roots anchor soil blocks that might otherwise fail through gravity and create landslides. Roots mean the soil structure, which allows water to be held rather than an impervious surface where it just goes off and becomes stormwater. So here's a very simplified root architecture diagram or illustration. When a plant is germinated, it puts down a taproot, which later disappears, except for a few trees like Oregon white oak, Gary oak, or madrone. But the root system develops fibrous feeder roots, which allows the tree to and water, and develops quite a bit of lateral rooting and deeply descending rooting, which are called sinkers. But rather than species specific, the actual extent of rooting depends on soil, geology, and hydrology of the site. So it can be very, very variable, very, very variable. And native ground covers and shrubs, especially evergreen, protects the soil, especially the erodible mineral soils, which are below the surface. So things like salal, sword fern, Oregon grape are really important components. You can see the roots in the picture on the right of the sword fern, and the roots can be several hundred miles long altogether, which is a lot of very small living root matter, which is holding soil and resisting any kind of surface flow that might occur. The organic rich soils are like a sponge, and they hold water and they protect the underlying mineral soil from the surface erosion. The leaf litter, the forest duff, the humus, all together create a very valuable natural mulch. But soil is much more than just a sponge. It's a very complex biochemical system with numerous mutualistic associations, which you may have been hearing about. It become pretty prevalent in the news, called the World Wide Web by some people, soil's communication highway. And you can see on the bottom right corner how small, how narrow that is, kind of like what Colin was talking about the phototropic zone in the marine environment. So it's a fairly thin protection for the soil mass which we build our houses on. It's a very complex place, and there's a lot going on. So shrubs, trees, ground covers, forest soils, they all work together to protect the landscape, to reduce stormwater, to reduce erosion, to reduce landslides. When that's all removed, there can be some serious problems. And we'll be going into that a little bit later. Right now, I want to talk about how trees on slopes grow differently than the upland trees. They're influenced by gravity, exposure, geology, slope processes. And it's a very inhospitable place to live in. If you've ever been to some places where mature forests still occur on the shoreline, you'll be amazed at some of the contorted shapes that they've assumed to be able to survive. Generally speaking, upslope roots are long and lateral, and the downslope roots are deep and vertical. So the lateral roots hold the soil and vegetation. The vertical roots anchor the trees. The site we're looking at in this photograph, most of the trees were removed for view. You can see the impact of the single tree left, and you can postulate that if the rest of the trees had been left on site, the slope would not have failed. An interesting thing that the lateral roots in a situation like this may extend more than 50 feet into the uplands. So this is an important consideration if somebody recommends a curtain drain or a French drain to reduce surface flow, because if you cut those roots during installation, that you can trigger that tree's falling, which will then take that slope that it has been holding. So you want to be careful of the roots from edge trees in your yard. Trees can also arrest landslides and hold slide debris on the slope. They create terraces and reduce landslide impacts. One of the most amazing things about bluff trees is they can adapt to changing conditions. Some of you may have seen the miraculous tree at Kalaloch, where a stream has been eroding under the roots for years, and the tree is literally hanging in by its toenails. The picture on the right shows a road cut where part of the tree was cut during the road cut, and in the ensuing years, the tree has adapted to the new conditions. So the stabilizing effects of tree roots can be pretty complicated if you are an engineer. There's a lot of math involved and a lot of calculations. I'm a simple forester, so basically I look at the more shear resistance you have, the better the factor of safety. So trees increase shear resistance and shear strength. If they're greater than the shear force, which is the force that is causing or could cause slope failure, then you're in fairly good shape. You can see the picture of that tree and how it is, the roots are kind of quilting the erodible soil into the bedrock or into the more competent geologic strata. Now, in the case of a deep-seated failure that John talked about, the structural benefits are negligible because the failure plane is well below the level of effective rooting. However, the evapotranspiration and the other hydrologic effects that I talked about earlier are still operating and may have a small to moderate effect on stabilizing the slopes. Mostly it's a water issue. If enough water lubricates that failure plane, then that would trigger the deep-seated failure. Now, I think we've made it pretty clear that different rules apply on the shoreline. They're tough places to live. So when we build and live near the edge, we've got to keep a sense of proportion. It's really a good idea to realize what is important and what isn't. Views are really important to people, but the cost of a trophy view may be too high. Cutting trees to improve views may result in slope failures. Beach access is also really important to people, but beach stairs can cause landslides and destabilize fairly stable slopes. So it's a good idea to explore low impact alternatives. You might want to have something a little bit more user-friendly than wiring several extension ladder sections together. Lawns are important to people. Lawns can cause serious problems for your slope. The compacted soil lawns are usually installed in can contribute to soil saturation, stormwater runoff, and of course erosion and landslide. Slope stability is critically important to people. Unfortunately, that may not be apparent until it's too late. So the uplands and slopes, when wooded, help to prevent stormwater, erosion, and landslides. When we develop property, and there's a less than 1% runoff from a forested upland area. After development, it's been logged, cleared, graded. The soils have been compacted, lawns have been installed, and the view has been cleared. You have up to 30% runoff from a typical rural residential area. Poor land development practices are one of the greatest contributions to stormwater effect. This is what poor site development looks like. The organic forest floor, ground covers, understory plants, trees and roots have been lost. The hydrologic and structural benefits of native forests have been lost, and the soils have been compacted, which makes them, in some cases, almost as impermeable as a gravel driveway. The results of poor development practices are dramatic and unfortunate. And what's even more unfortunate is that this could have been prevented. If you live below a steep slope, you need to pay special attention to upslope development. This happens to be the beach that I used to live on, and this is about the third house that has been scraped into Puget Sound in the last 30 years. So what can you do now? That was all very depressing, but there are things that you can do to improve conditions. And it's really important, and I'll keep harping on this, that you do what you can before you have a major problem, not after. The first thing to know is what are your site characteristics? Evaluate your property and realize that every site is different. John and Colin have talked about some of the unique site characteristics. I'm going to be focusing on vegetation. It's really important to learn the plants that are in the area that you live in because they can tell you a lot about the site characteristics. Madrone likes it dry, so that means you have a fairly dry site. Douglas fir, fairly dry. If you have a lot of willows, then you may have a wet site. Also, keep in mind that when you're on the flat, the soil under your feet is pretty much homogeneous. Whereas on a slope, it's kind of like a layer cake that you cut into. So the strata that John talked about, each strata has different characteristics, and their interfaces are sites that you can often see seeps or springs coming out. So it's a much more complicated landscape than the uplands. You might want to map your property's landscape, determine the environmental characteristics, and get an idea. I think once you've done that, you have a really good idea of the places that you might have problems. You want to look at potential problems in the upland, the slope, and the shore, and determine which issues are the most important to your situation and your security. That'll help you prioritize things that you might want to do. So let's talk about some general tips to help make your property less temporary. These folks had a very steep slope. They had good vegetation. They had a fairly stable site, and they wanted a big deck. Well, there was a tree in the way. Some people might have cut that tree and put the deck up, and they realized that that tree was one of the reasons that they had minimal landscape problems. So they built the deck on pilings. It was a west-facing slope, so they got plenty of light under the deck, and they're happy as clams and at high tide. You want to preserve and encourage the native vegetation at the base of marine slopes, like Colin talked about. Those are overhanging trees. The backshore vegetation and drift logs are all extremely important to maintain the nearshore area and help keep it healthy. Large drift logs and fallen trees on the beach both buttress slopes, resist land movement, and protect the shorelines from wave attack. You want to retain trees and other native vegetation on the uplands and slopes to the greatest extent possible. If you're going to consider removing a tree, you want to think about the factors that should be considered. They include the slope characteristics, the geology and stratigraphy, the soils, the hydrology. Do you have seeps and runoff? What's the nature of the erosion and slope failure in your area? What are the tree species and age? Is there hazard potential to residents? And don't forget to determine if the trees are on your property. Property lines very seldom are perpendicular to your house or your exposure. And unfortunately, a lot of people find that their neighbor's trees are in their way. And the last thing you want to do is cut your neighbor's trees, because I'm sure you'd rather be spending time on your deck than in court. Unnecessary tree cutting can contribute to landslide. And just remember, cut trees provide no benefits. Now, the problem is that there's often a time lag between cause and effect. So it prevents us from knowing how the results of our or our previous owner's actions will affect us later. Now, it's pretty sad that property owners often cut trees before selling the property. And so it can take years for the impacts of that action to become evident. So you buy your house right after the previous owner cut the trees to improve the view, and then there's a progressive root strength deterioration that can eventually destabilize or contribute to landslides. Topping trees is also a bad idea, because when you top a tree, there's a commensurate dieback of the roots, which is the last thing you want on a slope. You don't want to weaken the roots, you want to strengthen the roots and keep the tree healthy. Now, unfortunately, topping in many cases won't even improve your view for long. It can actually, over time, decrease your view and put you in the unenviable situation where you have to choose between a view and the stability of your slope. This illustration is pretty right on. You end up with more branches and more foliage on hardwoods than if the tree hadn't been topped. For conifers, the tree will basically re-establish its original trunk with branches from the side. However, that attachment will not be as good as the original one. So there are alternatives to pruning, to topping. Admittedly, alternative pruning for conifers is a simpler thing to do than pruning broadleaf trees. This is where it's very important to have a good arborist help you rather than someone that may not understand the intricacies of trees on slopes. You want to remove no more than 20% of the live crown during any entry. And you don't want to prune again until that tree has recovered the foliage somewhere else. So you're basically trying to redistribute the foliage so that it isn't in your way, but it's still supporting the tree's robustness. A well-pruned tree can enhance views and help stabilize slopes. Just, kind of think big bonsai on a grand scale. You also want to avoid clearing and extensive lawns to the edge of your bluff. You don't want to dump yard waste, like John mentioned, and you want to control invasive plants and not encourage their growth. Invasive plants are really bad news for slopes. They provide inferior stormwater and erosion control, and at the very least, you want to understand that trying to get rid of English ivy and other invasive plants is a difficult, complicated, and very expensive process. But you can't establish more effective native vegetation without controlling those invasive plants. That's a whole topic. It's very site specific, and conservation district, that would be one of the things that they would help you with during a site visit. At the very least, you want to keep climbing vines off the trees. Climbing vines such as English ivy, clematis, wisteria can add thousands of pounds of weight to a tree. They can also constrict its growth and in other ways impair its health. So if you decide you can't do anything else on a ivy infested property, at least keep the ivy off the tree. Now I have to talk about bamboo. I don't want to, but somebody's got to do it. Bamboo over the last few years has become a much more prevalent thing to be planted, mostly because the running varieties are very fast spreading and they're easy to grow and lucrative to sell. Bamboo has roots that can be impermeable to water at a depth of 18 to 24 inches. They spread by rhizomes, and rhizomes are basically lateral stems that sprout. And so they can spread quickly and they can create severe problems for shoreline landowners. And they're very difficult to deal with close to a slope. That's why I recommend if you don't plant bamboo within 150 miles of a steep slope. Unfortunately, you should probably be very wary of wildflower seed mixes because they often include invasive plants and noxious weeds. WSU has a program for pollinators, and they are offering seed mixes that you can trust. So you might want to contact your WSU extension office and have them send you a packet. There are many ways you can improve property management on a developed property. You can plant buffers. You can reduce areas of bare soil and shrink the lawn. In various ways, you can still have a lawn, but reduce its adverse impacts. You want to make sure that your drainage control is well designed and intact and operating correctly, and you want to control invasive plants. You want to work with your neighbors as much as possible because most slope problems don't pay much attention to property lines, similar to the nearshore area that Colin was talking about. And if possible, restore slope vegetation and improve your view management. I like to recommend that my clients consider a zonal landscaping approach where it's fairly formal near the house. You have lawn, you have ornamentals. Then you go into a transitional area a little further away where you mix natives and ornamentals. And then if possible, you go wild away from the house with primarily native plants. And on slopes and buffers, you want deep-rooted natives or natives that will help improve the hydrologic conditions. Now, some slopes, of course, are not good candidates for planting because they're undergoing severe active landslides. You basically want to suit the landscape design and plantings to fit the existing site conditions rather than change the site conditions to accommodate what you'd like to plant. So you need to adjust your aesthetic when you live on the shoreline. You want to preserve what you have and don't fight the site. I always recommend native plants whenever and wherever possible. They have a lot of qualities that make them a really good choice. And it's an opportunity to create a regionally distinctive landscape style so that when people come to visit, they see why you moved here. So you might ask, what is a native plant? Well, it's a plant which occurs naturally in a region, ecozone, or habitat without direct or indirect human influence. It's a species which evolved over time with the other plants in its biotic community. And most importantly, for our purposes, it's a species which has not been genetically altered. And this is important. Why? Well, when you genetically alter a plant, it's usually for blooms or leaf color or something, which makes it very attractive. However, you don't know what you're going to lose during that genetic manipulation. It might be its hardiness, it might be its drought tolerance, it might be its the tensile strength of its roots. It might be its ability to improve slope conditions. So I say stick with unmodified native plants that are suited to the area, at least in the transition, wild zone, buffer, and on the slope. There are hundreds of really ornamental native plants in the Puget Lowlands. Some of them are gorgeous, and many are also valuable for erosion control and slope stabilization. And there are some great resources out there. A couple as examples are vine maple and red flowering currant, which have actually become very popular in Britain. So the English garden is incorporating Pacific Northwest natives. Now, remember that slide I showed you about the root deterioration over time? Well, if you plant on the slope, then you can reduce the period of the greatest susceptibility to landslides by the regrowth as the original roots are deteriorating. You can kind of improve conditions, but that takes some, planning before you have a problem, because planting a slope that's just failed is closing the barn door after the horse is gone. Now, there are several criteria that you want to consider when you're choosing plants. You want them to be native to the area, appropriate to the site, with all of the cultural requirements. You want to have good bred and reproductive capability, superior erosion control value, good root architecture, and high tensile strength of the roots. You want them to be drought tolerant once they're established. Ocean spray, very common, very effective, and briefly beautiful. It's probably it'll be coming in about maybe a month. And it's a very good pollinator plant. So you want to plant for mutual multiple layers. If at all possible, you want to have a tree crown layer, tall shrub layer, a ground cover layer, and a forest floor layer. And this will help the hydrologic benefits that we discussed earlier, where you have water hitting the crown and then dripping and hitting the other crown and dripping until you don't have any surface water flow. Good for erosion control and slope stability, good for wildlife, good for water quality and marine life, and ultimately it would be good for you. Just keep in mind that it takes time to replace the lost functions to become effective. The good news is that vegetation becomes much more effective over time, unlike conventional engineered structures, which are strongest when in place and become progressively weaker and do not adapt to changed conditions. So you want to plan ahead before problems occur. Basically, you don't want to wait until it's too late. Thank you very much.